Thanks, Scott. So today's webinar, Advanced Corridor Modeling, fairly general term. There's a lot to corridor modeling. What we're focusing on and what we had mentioned in the advertisements is the use of auxiliary corridors. And so what we're kind of addressing here, the problem is when you generate complex multi-baseline corridors and you end up with a lot of miscellaneous profiles and alignments and regions and assemblies to keep track of. And really a lot of that is just necessary to model some of the corridors, some of the transportation projects we work in. But there's a number of strategies we can use to minimize the number of regions, assemblies, alignments, profiles. Some of you out there maybe are using conditional subassemblies. It's a great way to manage repeating things like driveways in a road project. So our solution, one of the solutions, what we're talking about today, is auxiliary corridors, and it's a concept where we can create, instead of independent or layout profiles, we'll create surface profiles. And it's going to allow us to create a much, much more dynamic model to respond to changes as they occur. So this auxiliary corridor will be a corridor built on the primary baseline itself of the actual real corridor that's modeling the curve and everything like that. So a couple of the examples, we're going to look at modeling a knuckle intersection or a cul-de-sac, depending on what terminology you use. And you might see this and say, well, I've modeled this before. I know how to do that. And perhaps you do, but I'm going to attempt to explain a few new strategies to use to model this in the most dynamic way possible. And that's really one of the goals when you're modeling corridors. You want to try to make your model as dynamic as possible so that when you make a change, you don't have to remember 28 different places you have to fix and update to get everything to look appropriate. So in this knuckle intersection, we're going to design the outside, or the design of the outside curve profile is what is fairly tedious, and this is where the auxiliary corridor comes into play. And we're going to also use an assembly offset for the outside curve modeling. You know, in this example right here, the alignment, the center line of the road is running right through here. But the curb, if you look strictly perpendicular out here, the curb doesn't want to model perpendicular to this. It needs to model perpendicular to the curb line. So an assembly offset is what gives us that power. And we'll look at that in more detail once we get to Simple 3D. The second example we have is an asymmetrical cul-de-sac. And it's kind of an odd one in that it has the 90-degree corner down here, not just kind of a whole bulb shifted, but actually the 90-degree corner. And again, we'll look at how tedious it normally is to manage the profile of that outside curb line. And what we're really after is some kind of 2% or 1% sheet drainage to certain corners or areas in the cul-de-sac. That becomes very tedious to model that as well. So we'll use an auxiliary corridor to create that profile. And then we'll also look at the target objects or objects that we'll use to generate this region in the cul-de-sac. And one of the things I'll mention is, you know, when you're modeling something like this, you always want to try to keep the corridor projecting perpendicular to curb lines. So it's not enough to simply run the corridor right down the center line here and just target way out here for one that wouldn't project our curb in the right direction. And we wouldn't have a ton of control on the actual grading of this cul-de-sac itself. So I'm going to jump into Civil 3D, but before we do, we've got just a few polls. We always like to see kind of where people are at, what tools they've used, and I think it's interesting for you guys as well. So this first one, Scott's going to throw up a quick poll. Just go ahead and click on the answer. Well, that's good to see. We've got, looks like about half the people always using corridors or consistently using corridors. And we do have a percentage of people who have never used corridors. So this is a slightly more advanced topic, but this will give you a nice intro to corridors if you've never used them. So let's get started here. We're in Civil 3D 2014, and what we're looking at is that knuckle intersection, or that knuckle cul-de-sac. And what we want to do is we want to model this, and we want to keep things fairly independent, or excuse me, fairly linked and dynamic. And what I mean by that is when the centerline profile changes for the roadway here, we don't want to have to manually change the grades along the curb line out here. So to start with, let's look at how do we model the this knuckle, and then how do we model the curb so that it stays perpendicular? Well, that's where the assembly offset comes into play. So first thing first, we'll start with our assembly offset. So I'm going to come over here to my assemblies. I'm going to make a copy of this basic assembly here. And we'll give this one a different name. The name of this one will be knuckle for the knuckle cul-de-sac. Then assembly offsets, if you haven't used them before, they're almost completely separate or independent assemblies, except they're tied to the stationing or the frequency of the primary assembly. So the way they work is I click Add Offset, and I can put this over here. Now when I model this in the corridor, I have to assign a second alignment and profile to this assembly. And what we're going to do is we're going to take this curb and this daylight sub-assemblies, and we're going to move that over there. Now the location of this assembly offset, its proximity or location to here makes no difference. Okay, this one is going to ride along an alignment that goes along the knuckle here. This assembly will ride right along here. So let's look at how that's going to work. I'm going to create an alignment off this polyline. So I have simple geometry drawn already. Create a simple alignment. The alignment name will be knuckle. Some basic styles, and a basic alignment. Okay. Now, what I need is a profile for this. Okay, I need to assign not just an alignment, but a profile to this assembly offset over here. In the profile, in this case, we want the grades to be a straight 2% down from centerline. Okay. This can be fairly difficult. The calculating of these grades out here gets fairly complex because the distance from centerline is always different. Well, we don't want to have to manually calculate that. So what we're going to do is we're going to create a surface profile along this alignment here, and the surface that we will use will be a surface generated from this centerline alignment. So this is where the auxiliary corridors are coming into play. So an auxiliary corridor is a completely separate corridor that you don't use to model the true corridor and the final surface itself. Basically, it's a means to generating surface profiles. So we're going to make a simple corridor right in the middle here that's not part of this corridor. And we're going to use this very basic assembly. All this is right here is a 100-foot wide link width and slope subassembly with a negative 2% slope. By the way, I already have a design profile up here for that center line. Fairly simple, fairly straightforward. Let's make a corridor. We will call this AUX for auxiliary corridor. The alignment will be the center line. Isn't that clever? Bin streak. The profile will be FG. The assembly will be the auxiliary knuckle assembly. That's the one right over here. Okay. We don't even have to set a target surface. Okay, we'll go ahead and set some of these station limits. I'm going to go from the beginning of this knuckle to the end of the knuckle. Right there. We'll also look at the frequency. We'll set that to 5 feet. Okay, if I go ahead and build this corridor, just a very simple corridor like that, 2% grade. Okay. I'm going to go ahead and create or turn on my surface as well. So that's in corridor surfaces. I can create a surface and I can add my top links. Okay, common procedure for creating a corridor surface. And I'll hit OK. And I think I may have a layer turned off here. Let's go in there. Yeah. There we are. Had the C-topo layer frozen. Let me go ahead and set the existing surface to no display. Okay, very basic surface there. What we're after now is creating a surface profile along that surface. So I'll click on the alignment, surface profile, and I want to make a profile, the aux surface. And I don't even need to see this in a profile view because I'm not going to draw a design profile. This is always just data that's linked to the auxiliary corridor surface. So I'm just going to hit OK and not even draw the profile view. And I know that it's always linked to this auxiliary corridor. Okay, from this point, I can turn off my auxiliary corridor. I don't need to see that. Now let's build the actual corridor then. We'll add that new region to this knuckle. So we'll click on Add Regions. We're going to go from right there all the way around to the end of the knuckle. Now we're not dealing with the auxiliary corridor here. This is the actual corridor, so we're going to use the knuckle assembly. Then we have some targets to set here as well. Existing, I'm going to match in there. And I'll come back to these targets in a second and we'll look at the rest of them. So for starters, it looks a little messy, right? Okay, over here is that, tell you what, let's move these assemblies a little closer. This assembly offset, that's what's modeling out here. Okay, if you don't assign alignment on profile, it just kind of hangs out wherever you set it in the assembly. So we have to come in here to corridor properties and we have to actually specify that assembly right here. Excuse me, that alignment, the offset to alignment. So that will be the knuckle alignment, and then what's the profile? The profile is that surface profile that we generated from the auxiliary corridor surface. I'm also going to tighten the frequency up quite a bit. We'll go to 5 feet on curves. And now what you'll see is this curve is being modeled right along that knuckle alignment. Okay. Now all we need to simply do to have this lane tie in to the curb line is to use our targets. So I'm going to assign a target to this lane left side here. So that's this one right here. And the target will be the knuckle alignment. Okay, that will manage the width of it. And we also will use the knuckle profile. Add that as a target as well. So those are like hang points where it attaches to. Okay. So another little poll right here before we come back to it. Scott's going to throw another poll up there. Targets are one of the most powerful tools in civil 3D corridors. If you have anything varying, slope, width, anything, it's almost always required to use targets. So those of you who may be a little newer to corridors, take a look at targets. They're going to kind of open all sorts of doors for you. So it looks like about nearly 60% of people are always using targets and consistently using them. So that's great. That's full corridor use. So why did we set this up this way? What's the point of this? Okay, the point is that not only did we quickly generate the profile for that curb line out there, but everything is linked, meaning that auxiliary corridor is built on the center line alignment and profile, just as the main corridor is built on it. So changes like this, changes to alignments or profiles, let's make a change to the profile, for example. Bring this up some. It's going to make a mess of it at first, but we have only to go to our corridors, rebuild the auxiliary corridor. Okay, that will now have reset the surface profile along the knuckle curb line. And then to get the main corridor to respond to that, we have to rebuild that one. Now the entire knuckle intersection has moved up or moved down or whatever we might have done. Okay. So this is a fairly simple grading model. You might be thinking, well, I want a swale line 20 feet off the edge here on the left. Okay. Well, if that's the case, put another lane to the left here. The inside lane will target one alignment. It goes right along there. And then the outside lane would target our knuckle alignment. Okay. So a lot of ways to handle all sorts of complexities in a knuckle intersection like this. Why don't we move on? We've got another example here, an offset cul-de-sac. Before we get there, why don't we make a copy of our region here. For those of you who might not be using the contextual ribbon for your corridor work, you're used to going to corridor properties. I always recommend when you get a corridor of any kind of complexity, meaning half a dozen baselines, a dozen regions, it gets pretty tedious to work in here. This contextual ribbon is really nice because you can click on the corridor, select copy region, for example. We want to make a copy of this one. We want to go from here right down to here. Takes all those targets and everything and just copies them over. Okay. And we can do other things in here, like editing the targets of just this region. I can click in here, and now I get the targets just for that. Or if I go to set all targets and corridor properties, I get a huge list of subassemblies and targets to manage. So coming down here, we're going to use a similar approach, but things are a little bit more complicated. So it's not just simple use of the auxiliary corridor, but it's also using targets in a smart way and modeling this in a smart way. Now, the way this looks, every cul-de-sac, almost everyone is different. The radius is different. You don't have a 90-degree here. Different strategies for different projects. Just in this afternoon, though, we've got time to show you one strategy for one type of cul-de-sac. So to start with, I'm again going to create an alignment that goes around the outside of my cul-de-sac. Using that polyline there. And this one we'll call the alignment cul-de-sac. We're very creative here. And we'll turn off the add curves option and hit OK. The basic alignment. Okay. So this is what we're going to model our corridor region on. But again, we need to generate the grades or the profile for that alignment. And most of the time, the drainage of a cul-de-sac or a knuckle, something like that, the drainage pattern is fairly simple. It's following some kind of centerline profile or some type of profile, and then we have sheet drainage. That's 1%, 2%, something like that, and we're draining to one catch basin here and perhaps another one on this side. So the actual drainage pattern is fairly simple. It's the profile of this outside curb line that's complex. So you want to spend your time on this auxiliary corridor generating that auxiliary surface so that your surface profile is quite simple. Some of you have used the drainage concept in parking lot grading. This is kind of building on that same concept, but it's almost even better than that because the drainage surface is built on the exact same alignment and profile as the actual corridor model. So it's even more dynamic than using some feature lines and grading tools and the whole drainage concept, drainage surface concept in parking lot grading. All right, let's look at our auxiliary corridor. What does that need to be in this area? Well, what we're going to say is that the crown comes in here, and the crown just continues. So it's a 2% sheet drainage to the east, and then it's also 2% sheet drainage to the west. And if we look at the profile itself, the centerline profile, we actually have a low point right at the center of the bulb. Okay, so we're actually going to be draining to catch basins on both sides, one right over here and one over here. So to create that drainage surface or that auxiliary corridor, we're going to turn on our auxiliary corridor again. And we're going to simply add another region to it. So it's real important, I can turn this corridor off and on. It's very important you use your object layers with the suffix wildcard to be able to allow this turning off and on. Otherwise, you got too much going on the screen. Makes it hard to work. So we're going to pick on this corridor. We'll select Add Region. But before we do, what are we going to build this out of? Well, we've got a different assembly up here. And this one's quite simple as well. It's a link width and slope subassembly on the left side that goes at a -2%. That's 25 feet. And on the right side, we have -2% and 135 feet. And those numbers are nothing magical other than widths that get us beyond the flow line, or excuse me, the lip of gutter of this whole cul-de-sac. So we just need to get beyond that. So adding a region, we'll click Add Regions. And we're going to go from this starting point there right to the end of the alignment. And I've actually run my alignment just a little bit past. Often if you run it right up to that lip of gutter, it can get a little messy and you might get a tiny waterfall on your surface at the end here. It'd be good practice just to run it slightly past. I'm going to use that auxiliary cul-de-sac assembly. We're going to skip the targets. We don't have any targets. I'm going to correct myself here. I said we're going to run this region a little bit past the actual cul-de-sac. So I'm just going to bring this up a little bit. And the reason is when we cut a surface profile, we'll be sure that it's within this auxiliary corridor region. So if I again go to my layers and I turn on that auxiliary surface, I should now see the general drainage of this cul-de-sac over here. So I'll freeze that stuff. We don't need that on right now. What about the assembly? What assembly are we going to use? Well, we're going to use the basic curb return assembly. We're going to run the curb around this alignment, and then we're going to take a lane subassembly, and we're going to target towards the inside here. And we're going to target both this alignment and profile. That's the center line. But we also need to target something else, okay? Because if I target this alignment from right here at station 1, it's going to shoot all the way over here. And then if I target from station 2, it's going to shoot over here. And everything's going to cross over one another. So we need another target in here just to manage the width of that lane. So what I have here, I have another alignment drawn in here. And this alignment starts right at the center of this bulb here. Then it goes just right on top of the center line alignment and profile. Comes right down here and then ends right at this corner. So what's going to happen is that lane, it's always going to target the first alignment and profile it sees, and it's going to always trim itself. So we'll get a nice kind of pinwheel look around here. And then the trick I'm using right here is we come around here with this curb return assembly. This target alignment is right on top of that baseline. So it's going to actually squeeze that lane right down to 0. And why are we doing that? We're doing that because we want to model this very simply. If I can do this all in one region, that would be ideal. One assembly, one region, much simpler to work with. And here's the trick. We can use that same auxiliary corridor surface as the target profile. So we're defining the entire sheet drainage of this cul-de-sac, and then we're just placing alignments wherever we need them to manage our corridor targets so nothing overlaps. So picking on this alignment, I also need a surface profile for this. And that will be a surface profile from the auxiliary corridor surface. And again, I won't draw a layout profile in there, so I can just hit OK, and I don't need to see it in profile view. Let's go up and make that assembly. I'm just going to go make a copy of this full road section, drop it down here, clean this up a little bit, and there's our curb return assembly. So we'll give it a different name, cul-de-sac for the name. Okay, so it's this lane right here. That's what's going to target the centerline alignment and profile as well as this miscellaneous alignment and profile. All right, let's go ahead and build this model here. I'm going to pick on the main corridor. And what we need to do now is we need to add a baseline. I've got an alignment and profile, but it needs to be added as a baseline. So again, I like doing this through the contextual ribbon. You pick on the corridor, you have add baseline, and I've got my cul-de-sac alignment running around the outside. And it also prompts me for a profile, and I didn't pick one yet. Why? Because we need to cut a surface profile of our auxiliary surface. So I forgot to do this on the cul-de-sac alignment. So surface profile, we're going to grab the auxiliary surface, hit the Add button, hit OK. Again, no profile view needed. All right, if I click Add Baseline again, we'll add the cul-de-sac alignment and the auxiliary surface profile. Let's take one last little poll here. We've been talking about auxiliary surfaces and corridors. Like I said, some of you may have used this concept in parking lot grading, but using simpler tools like grading objects and feature lines. Just a question for you guys. How many of you have used this concept of an auxiliary corridor or an auxiliary surface in your projects? It doesn't necessarily mean in a cul-de-sac or a knuckle intersection like this, but the idea of using some kind of secondary or auxiliary corridor to generate profiles for otherwise complex curve alignments. So it looks like about 80% of people said they hadn't before, and about 20% have. So that's great to know. Some people are doing this out there. Also glad we can be of help to people who haven't seen this before. All right, let's go ahead and model this corridor region. Picking on the corridor, we'd already made the baseline, so now I can pick on the corridor and select Add Region. And then it prompts me to select the baseline. We'll pick this one here. We're going to go right from here all the way around to the end of the alignment. The assembly is going to be the cul-de-sac assembly. That's that half road section. I'll hit OK. Okay, we have a basic target surface for the outside of the corridor. And then the targets for the lane, okay, that's what's going to model the entire pavement section of the cul-de-sac. Those targets, for the offset targets, we need to target the center line. So that would be this one right here. That's BIM Street. And then that small alignment that I had drawn already, this one right here, that one is cul-de-sac target. So we need to add that one as well. And we need to do the same thing for the profiles. We need to target the profiles. We're looking at the BIM Street finished grade profile, add that to the list, hit OK. Oops, need one more in there. We need cul-de-sac target and the auxiliary surface profile. Hit OK. And I modeled it. Okay, so what's important here? Why do we set it up this way? Well, if we look at this alignment, this target object has to come, like I said, right to the center here to trim or to stop all of these target objects here, or these lane subassemblies. We're targeting from this angle. It's hitting that lane, and it's not overlapping the lanes on this side. And as I said, as the assembly moves right along here, I've used just another trick to have that lane squeezed down to nothing. One of the things corridors are not good at, they're good at most things. A few things they're not. One is modeling the 90-degree curves or PIs in alignment. It doesn't really fan out in the way that grading objects will. So there's little ways you can trick this. And it's not perfect, it's not exactly how it would be built, but it's quite a bit closer. And what I had done is I took my baseline alignment. So this is that cul-de-sac alignment somewhere in there, right there. And I actually gave it just a tiny little, it's a curve with a radius of 1/100th. And what that'll do is it'll force the corridor to model around there. Otherwise we'll get a real kind of chopped off looking curve here. So it's not perfect, it doesn't come all the way out to this corner, but close enough, right? So we've got some frequencies to probably adjust a little bit here. Edit frequency. And we're going to turn off on profile geometry points, and I think we'll dial this up to about 5 feet. Maybe 5 feet on the tangents as well. So not excessive modeling, but a decent amount. Other thing you're probably noticing is it's not modeling right into this corner. So it's kind of an odd behavior sometimes. That's a PI on this alignment. And the frequency settings that I've set are such that it should pick up offset target geometry points. But I've found that sometimes when you have target objects right on top of one another, and it's supposed to be picking this up, I found that sometimes we'll miss it. Maybe you guys have found that trick. To make that work, what I've found myself doing is just adding a manual station. But before we can do that, we actually need something we can snap to. So what we want the station to go to is right there. Right up to the center point right here. And the reason I draw that line is because when I try to snap to that point right there, it ends up picking up station on the other side of the cul-de-sac, and it doesn't work out. So we need something to snap to that's really close to the baseline alignment. So I'll go back in there, edit frequency. We'll add a sample station here, additional stations. And I'm just going to do a nearest snap right on here. And it picks up that station, 28.71. And now it draws that right in there. Okay. Okay, maybe it seems like a little bit of smoke and mirrors. Well, it kind of is. That's the whole point of using auxiliary corridors. Is if you set them up correctly, it does happen that easily. Does happen that quickly. And again, changes are pretty easy to fix or to cope with. For example, if this profile, we'll go to that one again. Let's make a change on this. Instead of draining to the center of the cul-de-sac, let's instead drain to the back of it. So what I'm going to do is instead of having a positive 0.5 at the end there, we'll do a negative 0.5. We'll drain that all the way to the back. So again, what? All the profiles over here. The profile, the target alignment profile, that's all based on the auxiliary surface. And the profile for the alignment around the cul-de-sac is based on the auxiliary surface. And then the other target, the centerline alignment, well, that's the layout profile that the whole thing is being modeled on in the first place. So to update it, I simply rebuild the auxiliary, rebuild the full corridor, and now it's draining to the back. So this is the idea with auxiliary corridors. The idea is that you build a drainage surface and create surface profiles from it. And if possible, you build that auxiliary corridor right on top of the main baselines, your full actual corridor. That's what makes it really dynamic. Because when I make that profile change, that affects not only auxiliary corridors, but also full corridor. So what this looks like for different cul-de-sacs, for the most part, it's managing what these target alignments look like. Okay, there's some little tricks like getting the lane to trim off down here, putting little curves like this, but for the most part, you have to look at the geometry and target it accordingly. By the way, you guys can feel free to ask any questions through the chat window on your screen there. And I'll address maybe just a couple other situations on how you would handle them. We're not going to have time to go through them, modeling them in detail. But what if instead of having a crown on your cul-de-sac here, you instead wanted to sheet drain the entire thing to this side? Or maybe the entire cul-de-sac to the right side, so that we're transitioning from a crown in the main road to basically a cross slope in the cul-de-sac. Well, there has to be a transition somewhere. But for starters, we would modify that auxiliary surface or that auxiliary corridor assembly. We would set that to 2% positive. Okay, then I can come and rebuild my auxiliary corridor and also rebuild my full corridor. And for the most part, all the sheet drainage looks the way it is, or the way it should be. It's all draining to the east side here. But what we do need to think about is this transition right in here. I'm not going to go through it every pick and click, but what you need to do is you need to bring this region back a little bit. Okay? And you need to model another region in the exact same way we modeled this one, except for the profile right in here needs to be a separate layout profile. Okay? So that's a little less dynamic in that way, but there's almost no way around that. You have to manually design that transition profile in there. So again, you would back this off, target these same alignments and profiles. We could also do it a different way. We could run that cross slope right up to here and keep this back where it was, so right up here. And we could draw a simple feature line in from here, say right about there, to perhaps 75 feet back, something like that. We could take this feature line and set that up as a target, and we could transition from our 2% crown to a 2% cross slope. So we could put the transition in the main line. So lots of different ways to handle this. And we don't necessarily expect that this solution will work for every cul-de-sac or a complex corridor you run into. But you should always try to think about this auxiliary corridor concept. Is there a place for it? What should clue you in? What should clue you in is when you have a bunch of curb lines that are completely different than your center line alignment and profile, meaning they're not very parallel at all. Okay, so that's roundabouts. That's knuckle cul-de-sacs. That's offset cul-de-sacs like this. It's anything where the curb lines kind of have a mind of their own. Think about using this concept. And if you can, it should mean that your drainage concept, the drainage pattern, is based on your centerline alignment and profile. So next, roundabout you're grading, think about some auxiliary corridors. Should probably make the job quite a bit easier.